Hello, I'm Jim Ricotta, and I'm the CEO of Aliro Quantum, and we are all about quantum networking. We're a 3-year-old startup based in the Boston area. Our mission is to enable the first multi-purpose entanglement-based quantum networks. Our business model is software and services. We have many US venture capital firms as our investors from both the East Coast and the West Coast. And our customers are government organizations as well as commercial companies. We're a software company. We partner with the quantum hardware suppliers, like some of the ones on the webinar today. And of course, we also partner with classical networking suppliers who are key to building quantum networks, as well as some integrators that are getting more active. This is our building behind Harvard Stadium. We share it with 2 other quantum companies, so we're starting to call it Quantum Square. So now if you visit Boston, there's Harvard Square on one side of the river. On the other side of the river, there's Quantum Square. What makes Aliro really different is that we combine experts in quantum physics with people that have spent decades building the classical networking products that support the classical internet today. So our founder is on the upper left, Dr. Pri Narang. She's very well known in quantum circles on the faculty of both Harvard and UCLA. Over on the far right is Bruno Reisman, who many of you who are active in QED-C know. He has spent decades building large-scale service provider class classical networking products at places like Juniper and Lucent. And he also spent a couple of years before he came to Aliro over at QTech in the Netherlands, where where his alma mater is. And he learned a lot about and thought a lot about quantum networks. So he brings a great perspective of both sides. The rest of us also spent decades at places like Cisco and Juniper building high capacity, high volume networking products. Mike Wood in particular is very key. He came recently and he came out of the world of secure software-defined wide area networking, which is very relevant for one of the key quantum networking use cases, which is secure communications. So our solution is called AliroNet, and these are the applications we enable. And again, the idea of an entanglement-based network is just like a TCP IP classical network, you can run many applications on it, not just one. A QKD network can only do QKD, but an entanglement-based network can do clustered quantum computing, secure communications via teleportation, connecting quantum sensors, and also eventually distributed quantum computing and the quantum internet. So what are the problems we're facing now? We all know that the encryption that we use today is going to be hackable by a quantum computer soon. We also know that quantum computers don't have enough scale to do really interesting algorithms. As Mark alluded to, networking sensors can provide a lot more resolution for different applications. And then finally, something that we are really focused on because of our background in classical networking, the internet wouldn't have taken off if every company had a different way of doing everything and there was no interoperability. We used to have trade shows focused on interoperability of classical networking gear. And so we think this is a particularly important topic, and we're trying to address it with our software platform. So the solutions to some of those problems are based on entanglement-based networks. So with AliroNet, you can teleport qubits, maybe in addition to using PQC to give you defense in depth for secure communications. That's in the upper left. In a data center, you can connect quantum computers to get more qubits available to your algorithm. In the bottom right, networking quantum sensors, and over on the left, eventually with repeaters and other advancements that are coming, connecting quantum computers around the world. So let's drill down into AliroNet. There's 4 software products here. Up on the upper left is our simulator. There are open source simulators out there, but we found them lacking, so we built our own. It is very accurate in modeling the behavior of quantum networks, including the protocols for things like entanglement establishment and distillation and swapping and teleportation, but it also has a lot of physics built into it, so it can accurately model devices like the memories that we heard about, or the laser sources or the photon detectors. So that's something that you can use to simulate a quantum network and how it's going to behave before you actually go procuring equipment. On the right are our software products that manage and run quantum networks. The orchestrator at the top is a console for managing components, bringing them on board, configuring them, and then the controller below it actually controls the software that's sitting on the devices to make the entanglement and the swapping and teleportation happen. The red squares at the bottom are Aliros. That's our operating system for quantum networks, and it sits right on top of it's software and sometimes firmware that sits on top of the quantum devices themselves, which are the gray boxes. These can be laser sources, photon detectors, optical switches, quantum memories, and many other things. And the important part of our business model is we are independent of the underlying quantum hardware because we don't know, again, back to that interoperability point, no one knows which hardware is going to be a certain customer is going to want to use, and they may want to use a mix for different reasons. So we talk about the 3 operational modes of AliroNet. The first is emulation and simulation. So using software to design your network and then leading to emulation on actual hardware. Next comes the pilot mode where you build a small multi-node network. And then comes deployment where you're actually running an application like secure communications, let's say, on a network. Again, there's a lot of interest in quantum networks in the government organizations, with telecom providers, different kinds of enterprises, and there's integrators who are already actively involved. We saw that Accenture was on the last session, and in fact, we're working with Accenture on a very exciting quantum network project in Canada. It's in Quebec. It's in Sherbrooke initially, but plans to link Montreal, Quebec City, and Sherbrooke with a quantum network. We're working with some of the parts of the IC and the DoD, the DOE labs, and we have some other very exciting commercial quantum networks that we'll be able to talk about in the next couple of months. On the right, some of the companies we work with, and there'll be many more over the course of the next year. We're going to hear from Qubitekk. We just heard from Connect. Again, we're working with Accenture on this very exciting project in Canada, a commercial quantum network. And of course, the classical networking players play a key role in this as well. So Aliro's call to action: quantum networking is coming. It's totally different from classical networking. And you can read about it and study it. We encourage that, but there's no substitute for actually trying it and seeing how it works and what its limitations are and what its potential is. So we say, get in touch with us and start your quantum networking journey now with AliroNet. And I'll add another call to action, which is if you're a quantum physicist or a network engineer and you want to be part of the next big revolution in networking and communications, go to our website and ping us. Thank you.